Hello, in this lecture we are going to see the analysis of binary search. The binary search is also a type of divide and conquer method. This is type of divide and conquer method. We have to remember divide and conquer method. So first we'll try to find out what is binary search, the algorithm, how it works, how it proceeds, and then find the complexity. So I will have A of n, this will be A of n. As we know that in a binary search, what we are going to find out? We are going to find out a key value. What we are going to find out? Key value. I will have a number of elements and there is one key value which I have to find out. The step number 1, whatever the A of n is given to me, I have to divide into A of n by 2 parts, A of n by 2 parts. After that, I have to compare with key value. I have to compare with key value, and my key value will be either in this condition or this part or this part. It never be in a both part. My key value will be in either left part or right part. When I will compare the left part and right part, if I found in a left part, I have to solve only this part and find the key value. If this is not going to happen, then I will not find in this part. I will go to the right side part, solve it and try to find the key value. Now this part is going to divide into once again A of n by 2 part, and this will be A of n by 4 and A of n by 4. We'll try to compare my key value, whether my key is going to find this part or key is going to find in right hand side. I have to perform this division till the key is going to find, in the equation. As soon as the key value is equal to the array value, then I have to stop and I have to check where is my search value, that key value is going to find. So that by this logic, I will calculate T of n equal to the first part that I am going to divide into 2 parts. So that is T of n by 2. After that, my condition that the key value will be in the left part or key value will be in right part. So it is not in a both part. So there is only one T of n by 2. After that, if my value is not found in a single iteration, I have to do in a multiple. So n by 2 will be divided into again 2 parts. It's n by 4, it's n by 4. So either left side or right side, I have only one part value. It may be in a left side or it may be in a right side. It never be in a both side, either left side or right side. So that here is also only one part which I have to consider. So once again it must be only n by 2 plus what is f of n? At the last, what I will find out only key value, or I am doing the binary search to find only single value, that is the key value. So the f of n will be plus 1. So my final recurrence relation, T of n equal to T of n by 2 plus 1. This is the recurrence relation for binary search. I can write here, this is a recurrence relation for binary search. Now we have to solve this recurrence relation and try to find the complexity, so that we'll complete our analysis part. Compare with the master theorem, T of n equal to A of Tn by b plus f of n. A equal to 1, b equal to 2 and f of n equal to 1, which I can write n to the power 0. When I will compare with the master theorem, the condition A can be greater than or equal to, which is going to satisfy, b must be greater than 1, which is going to satisfy, and f of n is there, that is n to the power 0. when it is going to satisfy the minimum condition of master theorem, we'll solve master theorem first. N to the power log a by b, which I have to find out. So n to the power log 1, b is base 2. The log 1 all the time is n to the power 0 here. Why? Log 1 value base 2 equal to 0. So that my final answer is n to the power 0. So n to the power log a by b, when I will equate, my final answer is n to the power 0. In step number 2, I have to compare log a by b, n to the power log a by b with f of n. So in the problem statement, I found here n to the power log a by b equal to n to the power 0. And f of n in the recurrence relation is nothing but 1. 1 I can write in n to the power 0. So it is n to the power 0. When I will compare my left side to the right side, I found out that epsilon equal to 0. That means in the left side no need to minus, no need to add, it is equal. So by master theorem case number 2, I can say that t of n equal to n to the power log a by b into log n. N to the power log a by b I found here n to the power 0 into log n. It states that n to the power 0 is nothing but 1 into log n. That is nothing but t of n equal to big O of log n. This is the complexity of binary search. Then I will check in a best case, in a average case, in a worst case. So I have to compare in all the 3 different cases, and I have to inform that whether the best case what will the complexity, in a worst case what is the complexity, in a average case what is the complexity. In a best case, the binary search is always 1. How it comes? When in my array there is only one value, and the value is equal to key value. Value is equal to key value, then my best case is always 1. No need to go in divide and conquer, directly you can find the answer. So that is O of 1. In a average case, I have to perform all the activity till find the key value, so that it's O of log n. In a worst case, still I have to perform all the activities in a binary search using divide and conquer. It is O of log n. So with all the 3 complexity, will finalize that the analysis of binary search after the method and the recurrence relation by using the master theorem. The best case complexity is 1, average case complexity is 0, worst case complexity is, average case is O of log n and worst case is O of log n. So average and worst both are O of log n, and best case is O of 1. This is all about the binary search, where we try to find out the complexities using divide and conquer method, solve the recurrence relation by master theorem. So we can say that we have performed the analysis of binary search, and these are the final complexity in a best case, in a average case, in a worst case. Thank you for the listening.